Alright guys, welcome to this page of the notes, and what we're doing here is we're going to begin taking a look at that second objective, which is going to be solving inequalities, where you have a radical in the inequality. There's a couple of things I would like to remind you of. First is this. Whenever you have a radical, right, we want to avoid imaginary solutions, right? So what that means is we do not want negative numbers under the radical. So what's going to happen is if you have a square root of something, I'll just put an x under there for now, to avoid, right, to avoid this being imaginary, we need to make sure that everything under the radical is positive, right? We don't want negative numbers under the radical because that'll give us imaginary solutions. So what we have to do is we have to make sure that the x, whatever goes under the radical, this x must be greater than or equal to 0, right? Greater than or equal to 0 means 0 is okay. I can take the square root of 0, it's 0, no problem. Greater than 0 is all positive numbers, and I can take the square root of positive numbers, no problem. But if x were less than 0, well, now you have negative numbers. You're taking the square root of negative numbers, which are going to be imaginary, and I don't want those in my solution set, right? I only want real numbers. So what this means is actually these problems, inequalities that contain radicals, are going to require two steps. The first step, we're going to need to figure out, determine what values the radical is undefined. Undefined simply meaning you get imaginary numbers. That'll be the first thing we need to do. What makes the radicand, what's under the square root, a negative number, and eliminate all of those values. Then, step 2, we look at the entire inequality and solve that, which we know how to do thanks to some problems that we have already done. So let's go ahead and take a look at this first one together and see how this is going to work. Like I said, two-step problem where step number 1 is going to be to set the radicand, right? What's underneath the square root. I need that to be positive. I don't want to take the square root of negative numbers because that's imaginary. I don't want imaginary numbers in my solution set. So I'm first going to look at just the radicand. What's under the square root? And make sure that it's greater than or equal to 0. Step 1, take the radicand, which for me is 4x minus 4. It's whatever's underneath the square root, and that must be bigger or equal to 0. Greater than or equal to 0. What this does is this ensures that this will always come out to either be 0 or a positive number, which I can take the square root of. So here we go. Add the 4 to the other side. 4x greater than or equal to 4. Divide both sides by 4. This tells me that x needs to be greater than or equal to 1, right? If x were to be less than a positive 1, I would wind up with a negative number under the radical, and I would get an imaginary solution, which I don't want. So, whatever value of x you pick, it needs to be greater than or equal to 1 so that this guy stays positive and we get real numbers. I don't want imaginary numbers. Step 2. Now that I know what x needs to be bigger than, what? This is, I want this solve the inequality. So step 2. Let's go ahead and solve the inequality. 2 plus the square root of 4x minus 4 less than or equal to 6. Well, in order to get rid of the radical, I need to raise both sides to the power equal to the index. But before I do that, I need to get the radical by itself. Let's subtract 2 to the other side. So I'll have the square root of 4x minus 4 less than or equal to 6 minus 2 would be 4. Great. Now that I've done that, my index is a 2. We raise both sides to the second power because algebra says whatever you do to one side, you got to do to both sides. And because the index and the power are the same, they cancel each other out. 4x minus 4 is less than or equal, 4 squared would be 16. Keep going. Add 4 to the other side. 4x less than or equal to 20. 16 plus 4 would be 20. Divide both sides by 4 to get the x by itself, and x is less than or equal to 5. Now let me show you what this means visually by doing a number line. You don't have to give me a number line as part of your solution. I'm just simply going to draw the number line to help you guys see what's going on here and why you have to do these problems in 2 steps. All right? So let's go ahead and get my 0 in here. There's my 0, -1, -2, 1, 2, 3, 4, 5, 6, 7. That's far enough. All right. Part 1, or step 1 in this problem tells me that my x's need to be greater than or equal to a +1. So that's going to be a closed circle on +1. Step number 2 tells me the values of x need to be less than or equal to 5. That's going to be a closed circle on 5. And I have everything in between those 2 values. Now why? Well, here's the reason why. If you were to pick something less than 1, say 0. If I plug a 0 in here, 0 times 4 is 0. 0 minus 4 is a -4. I would be taking the square root of -4. The square root of -4 is an imaginary number. I don't want imaginary numbers. So all of these values less than 1 have to be excluded. They have to be eliminated because they would give us imaginary numbers, and I don't want imaginary numbers. That's step 1. Step 2 is actually solving the inequality. I need this side of the equation to be less than or equal to 6. So what that means is if I were to pick something bigger than 5, let's go with 6. Well, 4 times 6, 24. Yeah, no, that's all right. I'm going to wind up getting an irrational number, but that's okay. So 4 times 6 is 24. 24 minus 4 is going to be a 20. You take the square root of 20. It's going to be an irrational number, but you can go ahead and take the square root of 20, add it to 2. What you'd wind up with is something bigger than 6. But the inequality says it has to be less than 6. So I eliminate all of those guys because they would make this side of the inequality too big. It wouldn't satisfy the inequality. Therefore, the only values that work are between 1 and 5, including x equals 1 and x equals 5. Remember, guys, the way that we write these, it's been a while, but I'll remind you here, set builder notation is our favorite. That means you go ahead and set up the, that is a terrible bracket, I apologize. Set up the bracket. You write the variable first, since the variable is an x, and then we draw that bar. The bar means such that. So this is all values of x, such that, and then I need the values of x between 1 and 5, including 1 and 5. So it's all values of x such that x is greater than or equal to 1 and less than or equal to 5, and then you go ahead and close the bracket. That is the answer I'm looking for. I just drew the number line to help you see it, and I'll do that for the rest of the problems as well. If you like the number lines, please feel free to draw number lines. They're wonderful. It's a great way of visualizing what you're doing algebraically. Head on over to the next page of the notes. We'll try a couple more of these. I'll meet you guys over there.